Alright guys, so law of gravitation, that is what this unit's about. This unit's pretty much, it's short and sweet, but there's a lot of good info packed inside of it. Mainly what we're going to deal with is the inverse square law and how that relates to gravity. So you're going to have a lot of questions. Almost all of them are using the inverse square law. What you need to know when you go into this unit is that every object with a mass has a gravity. Okay, every object with a mass has a gravity. The larger the mass, the stronger the gravity. Two things affect gravity. Gravity strength, anyways. One of them we just talked about, which is mass, and the other one is distance. Distance is going to have a little bit stronger of effect. In other words, proximity, which is like how close you are to an object. So if you have two objects, and because our inverse square law, the force of gravity here, the universal constant of gravitation times mass 1 and mass 2, the two different objects, divided by the distance squared. So because it's divided by distance squared, when we're dealing with gravity, if we have two graphs, if we're talking about the strength of gravity as we move these two objects closer, that strength of gravity is going to increase exponentially. Okay? So what does that mean? Let's say you have two magnets, okay? So bam, I've got my two magnets, right? Notice there's not really any attraction. I'm just going to lightly hold them as I hold them right here. There's almost none at all, right? I can hold them. I don't feel any attraction at all. But as I get closer, notice that it doesn't increase evenly. It increases very sharply. That's an exponential growth. So as I get closer, if I lightly hold this straight magnet, there's nothing, and then boom, all of a sudden it's a very sharp increase. So that is a display of, now in that case it was magnetism, not gravity, but for our purposes it's going to essentially be the same thing. And likewise, as you have two objects that are very close together, as you move them apart, gravity drops off. In other words, decreases exponentially. So I have two of my magnets, or we could use this as our objects with mass. They're pretty hard, right? So it kind of pulls right back together. But as I move them apart, it's kind of hard to get them apart, it drops off so much that I can just have them sitting here and they don't really attract, right? So observe, gravity drops off sharply. This is why you always hear like black hole, it's so strong that light can't even escape. This is why we're not getting sucked into a black hole right now. Because the distance drops, as the distance increases, the strength of gravity drops off sharply to where it's like almost negligible, right? So that's what this unit is about. It's all about gravity. It's very straightforward, pretty simple. You got your formulas here, plug it, and that's it. Force of gravity, universal constant, which they give us right here, times the mass of one object, times the mass of the other object, divided by the distance squared. So if the distance is 10, on the bottom it's going to be 10 squared, which is 100, right? That's it, guys. Let's have a great unit.